right, for these problems I need to eliminate the parameter t from each of the following parametric equations. So it depends on what you have to begin with. Very often you want to solve each of the equations for t, if that's easy to do, and then you can just set the other side from t equal to each other, and that will work. That doesn't work well in this situation, but this is maybe even a little bit easier. What I'm going to do is I'm going to take x equals 3 sine t, and I'm going to divide both sides by 3 so that I have x over 3 equals sine t, and I'm going to leave that alone for the moment. And I'll do the same thing with the other equation, so y equals 4 cosine t becomes y over 4 equals cosine t. So in this case, I didn't solve for t, but I solved for sine t and I solved for cosine t, which actually works very well, because now what I can do, I know that sine squared t plus cosine squared t is equal to 1, so I'm going to square both sides of each of the equations. So for the first one, I'll get x squared over 9 equals sine squared t. And for the second one, I have y squared over 4 equals cosine squared t. So now I can say that I'm going to add the left-hand sides of the equations together, and that would be the same thing as adding the right-hand sides of the equation together because of all of the equality going on. So that would mean that we have x squared over 9 plus y squared over 4 equals sine squared t plus cosine squared t. And I still have t in the equation, so I'm not completely done. But at this point, what I can do is say that sine squared t plus cosine squared t is just equal to 1, as I said before. So now I have x squared over 9 plus y squared over 4 equals 1. And no more t. So, job finished. Question 46 works very similarly to question 45. It's just a slightly different identity that you're using with secant and tangent instead of sine and cosine. So I'm going to skip right to 47, which is still pretty similar but slightly different. In this case, I have x equals 4 sine t minus 5 and y equals 4 cosine t minus 3. So I'll add the 5 across, and I have x plus 5 equals 4 times the sine of t. And add the 3 across, and I get y plus 3 equals 4 cosine t. Now again, at this point, I can square both sides. I haven't divided by 4. Because I have the same number multiplied by sine and cosine, I'm going to leave that alone, and you'll see how this is going to work out in the end. So squaring both sides gives me x plus 5 quantity squared equals, squaring the other side gives me 16 sine squared t. And then for my second equation, I have y plus 3 quantity squared equals 16 cosine squared t. Okay. So again, I'll add the left-hand sides and add the right-hand sides. And that gives me x plus 5 quantity squared plus y plus 3 quantity squared equals 16 sine squared t plus 16 cosine squared t. And at this point, I've done everything I can with the left-hand side, so I'll go ahead and bring that down. And now I can factor a 16 because it's in common. And that's why, as long as the coefficient is the same, this works. I can do this factoring. So I factor out that 16, and it's 16 times sine squared t plus cosine squared t, which is, of course, equal to 1. So now I have my final answer, which is x plus 5 quantity squared plus y plus 3 quantity squared equals 16. And that's the end of that one. Now in problem 48, it looks very similar to what we had in 45 and 47, and yet it really is a very different problem. Because what I'll do is start out with the same strategy, which is get sine t by itself on one side. So x over 5 equals sine t. And then I do the same thing with the second equation. So y over negative 2, or I can just make this negative y over 2, equals sine t. Now before we had, one of them had a sine in it and one of them had a cosine, and so we used that identity of sine squared t plus cosine squared t equals 1 in order to simplify. But now I have the same thing on both equations. I have sine t here and I have a sine t here. So what this tells me is that since x over 5 is equal to sine t, and negative y over 2 is equal to sine t, then x over 5 must be equal to negative y over 2. And that's called the transitive property of equality. I don't know if they still teach that in algebra, but it is, that's what it's called. So if A is equal to B and B is equal to C, then A and C must be equal to each other. That's the logic that you're using. And this is not an algebra class, so I don't have to put this in slope-intercept form or anything like that. It just said eliminate the t. T is eliminated. My work is done. So this is a linear equation, but we're just concerned with eliminating the parameter t. So done.